Hi, statistics people. This is the first video about section 6.2, applications of the normal distribution. Back before spring break, when we were together in person, we talked about the normal distribution and sort of how it worked and how to use that table E. And now we're going to be doing some actual word problems. The document you're seeing on screen right now is what I would print out and give you if we were meeting together in person. I have it posted on Canvas. You can go online and look at it, and if you have a printer, you can print out your own copy. So there are two kinds of problems in this section. The first kind that we'll talk about is the kind that asks you to find the probability, or sometimes the percentage or proportion of values that fall within a certain range. And the second kind is kind of the reverse of that, finding a range for a given percentage of values. In this video, I'll talk about the first kind, and then there will be a second video for the second kind of problem. On this handout, there are several examples. Some have been worked through, but I'm going to work through example number 3 here. It says the average number of calories in a 1.5 ounce chocolate bar is 225. Suppose that the distribution of calories is approximately normal with sigma equal to 10. Find the probability that a randomly selected chocolate bar will have between 200 and 220 calories. So first of all, notice this is the kind of problem that asks you to find a probability. Find the probability that a randomly selected chocolate bar will have between 200 and 220 calories. Now, first I'm going to show you the sort of traditional, regular way of solving this kind of problem. And then afterwards, I'm going to show you two possible shortcut methods that you could use instead. But first, the long way. What we're trying to do is find the probability of X being between 200 and 220. Here, X stands for the number of calories in a randomly selected chocolate bar. So first thing we need to do is take these numbers, the 200 and the 220, and convert them into z-scores. So for that, you'll need a calculator, and you will need to know the mean and the standard deviation. Here it tells us that the mean, that is the average, is 225. Oops. The mean is 225, and the standard deviation is 10. Remember, that's what that sigma symbol stands for. So to calculate the z-score, you get your calculator, you type in parenthesis 200 minus the mean, which is 225, close parentheses, divided by the standard deviation, which is 10, and we got negative 2.5. For the other number, the 220, the z-score is 220 minus 225 divided by 10, which is negative 0.5. Now, sometimes you're going to get more decimal places than this, and you're going to want to round to 2 places after the decimal point for your z-scores. Here it came out so that we didn't have to worry about rounding. So in terms of z-scores, the z-scores go from negative 2.5 to negative 0.5. If you remember what we talked about back before spring break, when we did section 6.1 in class, you know what to do next. You go to table E and you look up these z-scores. I'll do the bigger one first. I'll look up negative 0.5. And since it's just negative 0.5 without another digit after that, it's negative 0.50. We're looking in this first column here, and it gives us a 0.3085. And then for the other z, the negative 2.5, we find 0.0062. So what we need to do is subtract those areas, 0.3085 minus 0.0062. And we get our answer, 0.3023. So that is the answer to the problem. For part B, to find the probability that it will be less than 200 calories. So that would be the probability of X being less than 200. So again, we start by converting that number 200 to a z-score, and we already know what it comes out to be. It comes out to be negative 2.5. So now this is the probability of z being less than negative 2.5. And for that kind of problem, we just look up the negative 2.5 on table E, and we get our answer, 0.0062. And then for part C, we want the probability that a randomly selected chocolate bar would be more than 230 calories. So that would be the probability of X being greater than 230. So we got to convert 230 to a z-score. So that would be 230 minus the mean 225 divided by the standard deviation 10, and that's positive 0.5. So now we want the probability of z being greater than positive 0.5. We go to table E, look up positive 0.50. It gives us 0.6915. But since we want the probability of z being greater than this number, we need to subtract this area from 1. We need to take 1 minus 0.6915. To get our final answer of 0.3085. Now, as promised, here are the shortcut methods. One shortcut method involves using a graphing calculator. So if you don't have a graphing calculator, you can't do it this way, sorry. But if you do, that makes it easy. We need to go to the distributions menu. So click second, and then the button that says DISTR above it. And we want the second thing on the menu, normal CDF. We give it a lower and upper number. So for part A, the lower number was 200 and the upper number was 220. The mean, mu, was 225. The standard deviation, sigma, was 10. We paste that. Whoops, that's not what I meant to do. Let me go back to the screen here. Okay, so we paste that into the calculator's main screen. It's going to show up as normal CDF 200, 220, 225, 10. And if you have an older model of graphing calculator, you might have to type this in directly yourself, just like that. But now when I hit enter, it gives me the answer, 0.3023, and then some more digits after that. To do part B, I would ask it for normal CDF. And since we want everything less than 200, the lower number would be something that's way below 200, like maybe negative 9999. And then the upper would be 200. And still the mean is 225 and the standard deviation is 10. We pass that, it gives us the answer of 0.0062. For part C, more than 230, normal CDF. This time the lower limit is 230 because we're going from 230 on up pretty much forever. So I put in a really big number for the upper. And the calculator gives 0.3085. The second shortcut method is, now this is an online app that I have a link to on Calculus, or on Canvas, sorry. So if you click on that link, it will take you to a screen that looks sort of like this. You want to make sure normal distribution is selected. It should start out being that way. You go ahead and fill in the mean and the standard deviation in the boxes where those belong. And then depending on which kind of problem you're doing, probability of x being less than a number, or the probability of x being greater than a number, or the probability of x being between two numbers, you select what you want, put in the numbers, hit the calculate button, and it gives you the answer. So the answer to part A is 0.302328. The answer to part B, the probability of x being less than 200, was 0.0062. And the answer to part C, probability of x being greater than 230, was 0.3085. So that's how you do the kind of problem where you find the probability that a randomly selected value would be within some certain range of values, either between two different numbers or just below some number or above some number.